and welcome back to another episode of From the Field. I'm your host, Casey Orr, out of Auckland, New Zealand today because I am in our studio. I'm normally Wellington based. Last week we covered off how to query your AWS account to find instances and relationships and where EC2s are talking to each other in different ways. But in the old adage, if you think it's a good idea, someone's probably made it and made it better. So that is when someone in the chat, which I really appreciate, reached out and said, "Hey, this sounds a lot like SteamPipe." So if you want to do that, use SteamPipe. It's a awesome open source integration type of tool that allows you to query directly against numerous different data sources. Today, we're not talking about that. We're talking about how to cost optimize your data infrastructure, which is really quite a nuanced topic because there's lots of different places where you touch your data infrastructure. And this is where we have Zen, which is one of our awesome AWS solution architects based in Auckland as well. So, Zen, why don't you introduce yourself? And then after that, tell us what was the first programming language that you learned?
Right, thanks, Casey. Hello, everyone. My name is Zenu. Just call me Zen, as easier. I'm the senior solutions architect based out of Auckland. Look after our awesome software and digital native business service line. But I'm also working sometimes with some of our enterprise customers to help them build awesome platform on our AWS environment. Very good question. In terms of the first language I learned, I don't know anyone will recall this name is called VisualFocus Pro. Very old technology, about decades back when I first started to look at handling the data. We use such sort of DOS-based UI to program the database. It's a VisualFocus Pro. And sometimes I still see this terminology coming from the textbook.
Yep.
Yeah. Over time, Pascal, which is still an old name, Fortran, I've touched a little bit. Nowadays, mainly expertise on data, I mainly use SQL and Python. Well, I'm helping my customer build the data platform. Really, really interesting. Cool.
Nice. I think it's for data, Python, R, and Scala are the main ones that you interact with these days.
The Python, Scala, yes, they're the most language I'm working on at this moment, particularly.
Cool. And last question before we jump into it. What was the first big project that you worked on, and what was it?
I worked with a few really giant projects, mainly around the global rollout for some BI and the data warehouse environment for a global leading chemical industry company. For their master data exchange environment that's across 3 continentals, Europe, Asia Pacific, and the North American region. It lasts about 6-12 month period of time. Multi-staging environment, a multi-staging project, and complicated environment hybrid with some cloud, like I'll say, private cloud and public cloud at that particular time, and SAP also be included. Really exciting. We follow the Sun strategy to roll out that master data platform globally. Yeah.
Awesome. And then finally, just so the viewers know what we're going to be covering, can at a high level tell us, like, what are we going to be covering, and what can people expect from this stream?
Right. Yes. The reason why this topic come into play is mainly due to the current microeconomic situation or conditions. A lot of focus has been put back to from building the awesome innovation features back to the cost optimization. And as Casey just pointed out, we've put a lot of focus on the EC2, on the computing infrastructure. In the past, we optimized that bit quite a lot. And the customer is knowing a lot of good techniques, tools, architecture patterns for optimize the computing infrastructure. Now, the data strategy become more and more important. The machine learning coming to the play, and your traditional data stores and the modern data stores has come into the play. And if you look at our customer base, the compute is no more the top 3 consumption in their AWS bill. sometimes the top one bill is their database, their data infrastructure, DynamoDBs, RDS. So the customer is putting a lot of focus to learn more about how to optimize that part of their infrastructure in AWS. But we don't talk that very often. So that is the main reason for this topic to come into the schedule for today, as well as in today's session, we're going to cover the data infrastructure, right? It's data infrastructure not limited to your database environment, not just your RDS, not classic RDS. We're also going to cover some of the Redshift and as well as some DynamoDB. And I will also give everyone some live cases, which I experienced that helping the customer to reduce their data infrastructure costs, and how do they pass this cost reduction even better to their end users to gain a lot of customer satisfaction. So stay tuned. That's
Yeah,
pretty much
definitely.
what we'll cover today. Yeah.
Yeah, it sounds like it's going to be really awesome, and I've also seen a couple of slides already, and it sounds like it's definitely going to go quite in depth at times. So it's going to be an awesome stream, and I'm looking forward to it, Zen. So with that,
Yeah.
why don't we
Okay.
jump into it? Let me just bring up your slide deck.
Thank you very much. Okay, let's quickly jump into the second slide. Cost is also, we all know security is the top priority in AWS, but cost is also another one because that's the key features that will be delivered from the cloud computing technology. So have a look at this. Do you think how many times AWS has passed down to our savings into the price reduction, which is your benefit? It's 129 while I'm building this slide deck. It's really, really, really amazing because we always try to pass our cost savings into our customer. So do you. I think learning today's technique will help you to reduce your not just your platform cost, but also will give you the opportunity to pass on these cost reduction to your end users to gain your customer satisfaction and also boost your customer retention rate. So we'll give you some real examples from the next couple of slides. Okay, so I've already mentioned because of the current situation, the customer has got a big challenge of reduced AWS bill, but main focus is on their EC2 environment to compute, whether some low-hanging fruit that easy execution like savings plan, reserved instance, which is everyone already know this terminology and techniques, using the cost explorer, budget alert to measure and make your AWS cost visible. So these are the things that customer will use in the operational environment. So DevOps team and usually will do. But look at the DBA and also the developer, the DevOps, the dev side, how these each line of your code you written, will that have the cost implication? That we'll deep dive into in today's session, right? So first of all, in general, there is some very common techniques we call the 5 pillars of cost optimization. Most of the customer well already aware of is, which is right size your resource, increase the elasticity. You go up and down with your demand, go up and down using the RDS elasticity provisioning, and also pick the right price model, right? So that's the sometimes we look at, do you have right reservations? Do you have the, for example, if you run your database on your EC2 instances, do you use the Spot instances or any other, for example, different architecture like the Graviton to give you the direct cost savings? And also, more importantly, because the volume of the data is growing dramatically, significantly over time, optimize your data storage is another important key success action that you need
And
to do. Yeah.
Zane, I just want to jump in here. And also, when you're talking about these 5 pillars of cost optimization, especially when you're talking about right sizing and increasing
Yeah.
elasticity, you also want to make sure it's in context of the reliability that you need from that platform and also from that workload. Because I have seen people cost optimize a bit too far, and that's introduced reliability issues into their platform, and they've had to essentially they've lost trust. And once you lose trust with your customers, always exponentially harder to get it back. So
Yeah.
just make sure that you don't essentially, cut too deep with the scalpel. You just need to make sure that you are doing, you're right sizing based on the needs of that workload.
Correct, absolutely correct. So this is the fifth pillar coming to play is your measure and monitoring and continuous improve. You need to make sure you don't cut your size quite significant or quite ambitious. Just go step at a time because we do see some bad impact because of the right siding exercises and impact the end users. Yes, that's for sure. So I will share some real life cases for the customer, how to correctly leveraging the right sizing techniques and increasing using the elasticity and some architecture patterns to overcome the negative side of the cost reduction or the sizing issues. Cool. So before we actually started the cost optimization, another thing we need to talk about is to understand the cost model of cloud compute of AWS, because traditionally, from particularly the DBA or the developer's perspective, the cost is already provisioned. We won't think about the upfront capex that much. But in the cloud context, in the cloud environment, pay as you go, and also the auto scaling, especially around the storage I/O. So we will deep dive into the RDS I/O and IOPS in the next couple of slides. So this is very important, I would say, mindset switch from the traditional data store or relational database management to the cloud-based data infrastructure. So very, very important. So you need to aware of everything because your database system is no more free of cost because you already upfront the capex that. So each individual one, okay, you need to start to think about where is the cost implication. So when we look at the RDS, where is the cost structure? Each individual one, we break down into 5 different categories. The license and the tenancy can be one cost element, and the instance type for sure, and your pricing strategy, whether you're reserved or not, and also the storage impacted quite a lot. We will see some real life customer examples that the I/O and the storage cost start to taking over the instance or the compute cost while they start storing more data, and also they want to collect more user information, and also the I/O, the queries they put through into the database system creates quite significant impact of the cost. And operational maintenance, like your database log backup is one big thing, and also your data transfer, your cross-region backup, your cross-region DR solution, these will have the operational impact to your database cost. Of course, the architecture. So basically, when we talk about the TCO, we will always leave all of this physical, I would say, point of time. These the first 4 are most of them called the point of time cost impact. But architecture has a long run ongoing cost implication. Whether you're using the modern architecture to reduce your cost and continuously modernize your environment, that will be a very, very important topic. For example, let's say the RDS environment, there's a SQL Server or relational databases. These, I would say, the foundation model, the relational model has been developed maybe 2 decades or 3 decades ago. At that time, the storage cost, the reason why people develop relational model is to avoid really, really high storage costs to reduce the redundance, right? But now storage has become a commodity. On the other hand, the compute maybe become a not cost-effective compare with the storage. Whether you still need to use these relational database to store your data is questionable, right? So building up a modern data platform will give you the cost benefit from the cloud native architecture perspective. So this has become a more and more important topic for all architects or data engineers to look at, instead of selecting the right skills, selecting the right storage, and do a lot of like operation excellence activities. So this slide will just break down into each video in details of each category of the consideration point or the cost impact point of the instance. For example, your storage, what is storage type, IOPS, and also the architectural cost, right? What is your horizontally explain, and also whether you got multi-AZ, whether you modelize that, whether you use your proxy. So all of these things will have the cost implication. Now, once we understand what is the cost implication point, what is the TCO of your RDS instances, let's break down into each individual categories to see how it's going to impact you and how do you use some techniques to optimize your environment. Okay, so first of all, I don't want to be overwhelmed for this particular slide, because you can see so many sizings, instances in your environment. What we will try to cover is find the right size, use the more generic category first, and then continuously optimize your environment. Use the general purpose first and find out what is using the monitoring and also using the feedbacks from your load testing and also from your real life monitoring, your metrics in the CloudWatch environment or your application monitoring, performance monitoring environment, and then continuously move from the left to the right to optimize your environment, your RDS SKUs or your instance types. Now, you don't need to make things right at the first place, because continuous optimization is a key principle for getting a long run or operational cost benefit. And also, I would recommend, if you have your AWS solutions architect, just to keep in touch with them. They will give you the feedback them with your data, with your information. They will help you to find some most good roadmaps of how to transit from one point to another, because that is our contributor, our value, and our recommendation to our customer. For example, I helped one customer to move all of their Intel-based environment into a ARM-based, Graviton-based instances, and directly gain the 32 or 33% cost benefit from just that convert. And we will provide a certain level of roadmap and guidance for the customer to move on. So this is the instance type that you can directly benefit from right sizing and without impacting your environment. Okay, so the CPU utilization, for example, is one of the compute optimizing technique that most of the DBA and also the infrastructure people will use. So that is why the monitoring and the right metrics is very important. In the cloud environment, what the principle is, we try to eliminate the waste. So that is what we are trying to pump the peak CPU utilization, the monitoring into 90 or 100%, just to push your application or your database instance to the limit. Traditionally, I've seen many safe threshold is around 65% or 60% in most cases. So this is sometimes what we're seeing a lot of, like the traditional provision for peak principle coming to play. But in the cloud environment, the compute optimization should be targeting 95% of utilization. So this is very, very important. So that also give a little bit of pressure to the ops team to set up the right monitoring mechanism, to know what's the cloud native principles in here, to continuously leveraging some automated mechanism as an operational element to help to support, we can push the compute optimization into the limit.
And from an application side of things, when it
Yeah,
comes to relational databases, generally the thing that causes high CPU loads is joins and aggregations. So if you are experiencing high CPU loads, then you can also, the first thing I would look at in my application would be excessive joins or excessive aggregations. And if you can also optimize that at the application level to reduce the need for you to increase the size of your instance as well. That is something that I would highly recommend.
correct. Thanks. You just revealed some of the techniques and slide we'll talk about in the IO cost optimization. Thanks for that, Casey. And also another thing is we'll see the more and more memories of load type of workload has been coming to the application side. Traditionally, we'll see some application is memory hand, particularly around scientific or the financial institutions. All of their databases is processing the large volume of big chunk of data. So the memory load will be really, really high instead of the compute, because they are not doing many compute at that time, but they are loading a large volume of the data to serve the front end. So that is, especially we pointed out that SQL Server could be a bad candidate of eating up your memory. So optimize the memory by modernizing your environment is also very important. So the freeable memory, which is not the memory usage compared with the old metrics, is very important to have a look at of it. Then once we start to have a healthy freeable memory, so we can push or find using that technique to find the right compute instance. Either it's a memory optimized or either it's a computer optimized to give you the best, I would say, the memory and the CPU ratios, because sometimes the ratio is very different from instance to instance. And also the storage optimization is mainly around optimize your IOPS. But how do we optimize the IOPS? That's another, there are a few techniques I will talk about in the next few slides, but the storage type will give you a quite good impact directly into your cost saving strategy. For example, GP2 and GP3. This is a no harm directly convert or directly adoption of latest. So always use the latest version or the latest generation of AWS services will give you that cost benefit. So this is no harm. And also there are a lot of good features that GP3 can provide. For example, provision the IOPS, you have more flexibility to control your IOPS to optimize, because outside compute and storage, IO also cost you quite a lot. Here, I give you a real life example, because I have another customer. So their main purpose of the application is to collecting the web click and also the web click information and the user behavior. Pretty much the IO pressure is much more bigger than the actual compute side, because they don't need to do a lot of the compute on their RDS environment. They do a lot of IOPS access and analyze all of these data. So their IO cost is 3 times more than just the compute cost in their AWS bill. So we use some optimized skills, particularly tuning their SQL queries and user behaviors, and we managed to reduce 25% of their total IO cost. from the traditional 6 figures high IO costs and controlled it into a manageable and acceptable cost within just a couple of months. So that's another thing is we need to understand our bill, because in your AWS bill you will see two line items regarding the SQL or your RDS environment. One is the non-instance, so there will be a comment on your line items which is called non-instance type of cost. So these costs usually associate with your IO. So if you see this line item is taking over your actual SQL, your instance cost, which means you are either, like Casey said, writing some very bad joint query or large query to skim your databases, which usually a classic behavior for the classic DBA or the database developer saying, yep, the database is no cost to me, so I will just skim over everything to get what I need, large joint queries, or either your write behavior is not optimal. For example, and also during some DR situation, your read replica will start to doing some dodgy behavior. So we will talk about these techniques to optimize our IO in the next few slides. Hopefully that will give you some insights about everything. Cool. And also selecting the right edition of your database will give you some, particularly around your commercial database edition, your SQL Enterprise and your Oracle database selection will give you some really, really good cost impact. Will give you some significant cost impact as well. For example, the SQL database mirroring, we can leveraging the SQL Server multi-AZ. So I will always be questioning, do you, especially when you're seeing the always on the failover cluster, and also when we start to selecting the CPU SKUs, and there will be some good techniques to downgrade to the SQL standard edition if you are not using more than 24 cores, and also your other feature required for enterprise version can be overcome by architectural techniques. There's a really, really, really good point that do not always rely on these features, but rely on some architecture patterns to meet your requirements for these features. And this is another side-to-side, like side-by-side comparison of the architectural pattern that you can use for meet the requirements of some features that only provided by, for example, the SQL Server Enterprise Edition. And also from the license perspective, we have another mechanism called OLA that can help you to have a look of your license cost and optimize what you will need to lower your TCO of your RDS environment. And if you are interested, talk to your AWS account team. And there's another cost usually will be overlooked by, or some cost is not aware of by the DBA or the ops team, even the infrastructure, which is the data transfer cost. Because traditionally we're seeing the multi-region backup, transfer your read replica from this region to another, and also our global database will automatically replicate behind the scenes. So these are sometimes the hidden costs if you run on the EC2 instances, as well as on the RDS environment. You may not directly aware, because that's not a part of your billing line item. That's not a part of the association with any SQL or RDS environment. It's just a data transfer. We have seen some use cases. The customer has top 3 consumption. The third one is the data transfer cost. So at that particular time, that rings the bell. You need to look at where these data transfer costs come from. Most likely, if you have a very complicated SQL multi-region environment, this is where the data transfer costs come from. So in the earlier this year, I have helped one customer, it's a real life example, to review their DR strategy and really challenge or question whether they will need a multi-region the multi-region DR strategy, because this customer spend more than 2 million on AWS every year, and their database cost, RDS cost, is the top 3 costs. So they want to reduce all of these. So end of the evaluation result, they move back from the multi-region DR to a multi-AZ DR strategy. That significantly reduced their cross-region data transfer and also simplified their environment. So really, really think about it carefully when you start to run things in a multi-region environment. So that is sometimes by default, so we need multi-region, but you need to be aware of the cost implication, and whether it's necessary just enough is another principle that everybody need to consider, especially when you start to replicate data across the region.
And unrelated, in general, if you do have high DTO costs and your business is not really around streaming data out, then you should instantly get in contact with your account SA and also do an internal review, because it generally means that there's a misconfiguration, or maybe there's been, as you said, a decision that's been made that hasn't been fully thought through, because your DTO shouldn't really be in the top line items unless you're in specific industries.
Yeah, exactly. That is something really, really not just related to your data infrastructure, but your data flows. And sometimes the SIEM or the new firewall solution maybe cause that implication as well. That's some techniques, because once the firewall start to inspecting everything, they will have the transition gateway, and all the traffic flows start to flying everywhere. So that will give you a cost, DTO cost. So monitoring is very important. Ring the bell again. Monitoring, have the cost visibility, also very important. So you will know where your cost goes, and if you're there, then anomaly point, so you will aware of that and action on it immediately. So cool. So other than just the traditional RDS, so Aurora got some other new nice features, and something sometimes it's slightly different cost structures. So that is the summary of especially the green area. Is the RDS or the Amazon Aurora cost dimensions. For example, the blue-green deployment will give you extra cost implication. It's not a free service that you need to aware, because I still remember on the day one that feature being released, a lot of customers asking, "Oh, can I enable that? It looks like a cool." But yes, be aware of the cost implication if you want these cool features, and also for example, the Aurora Backtrack, and also fast database cloning. Though these all features has a cost implication. If you want to leveraging these new features and use cases, have a read of carefully about the price sheet, then you will understand what can be implicated, especially around these fast clones. Considering your data volume is really high, that can be a big cost impact. Cool. Why we separate the Aurora into a separate slides, because I don't want to emphasize more. The storage cost can be optimized from case by case. The thing I want to deep dive into here, first of all, is the serverless environment. Okay, so once the environment you start adopting the serverless, the things can become more interesting, because you're not managing any of the server. You start to managing the ACO, the computer unit. So that is some other new techniques that you need to monitoring, especially around which metrics you want to monitor, the serverless database capacity. And it's not I would say a tangible entity, a server or instance that you can manage. So there are very, very different techniques. And also the IO, the IOPS, as I just continuously emphasize, is very, very, very important. It got really, really good cost impact. Particularly, we will divide that cost into two parts. One is the IO cost. One is the read IO, because most of the time the database operation is on the read and query joins and a lot of these things. So what is the read IO depend? first of all is the cache size, and the cache size is mainly dependent on the instance size and the data access pattern. So that is a very tricky point because that becomes related to your daily development work. So your code is no more a free code that will always have the cost implication that are always trying to ring the bell to all the developers. Now each line of code that you check into your Git repo will have the cost implication, regardless what environment you are working on, regardless what application you are working on, Lambda, SQL. So the access pattern, as just continues to point out, will have that cost impaction. Okay, so what's the metrics that the pricing unit will be number of physical pages read, and also the minimum cost unit is 1 per million requests. And what is the monitoring mechanism is the metrics is the volume read count IOPS by CloudWatch. So the cost optimization tips is fine-tune your SQL queries to optimize the read operations and avoid additional, particularly the full or large row scan on table, and also avoid large joint query to just to give you whole everything. So the database philosophy, DBA philosophy I use to do that is I need everything. So you don't need everything now, you just need just enough information that you need to do. And also use the two automatic trunk process on the Aurora Postgres SQL for high DML operations to avoid any blockage on the table and index access. So like this, the last one is I don't see many customers start using that is to understand that Aurora IO, especially the feature parallel query, that's really, really helpful for optimize the read. For example, in my cases, the customer end up adopting a lot of the Aurora parallel query to improve the performance and also reduce the IOPS cost as well. Cool. So here is some examples. Oops. So if you examine the 10 rows traditionally and also the rows ended by 2 and extra rows proceeded is 8. So what we recommended is to review your SQL query, make it more efficient index, right? And the data page count at the extra pages you shouldn't read, though that waste of IO. So like 80% of your cost has been wasted. So this is something we really need to evaluate in your environment and also your techniques. And also the other side is the write cost across your different AZs. That's exactly the same. The write size is always being priced by a 4K size unit, the traditional database block size, and per million requests for 4Ks will be charged as a total unit. And also the key metrics to monitoring is the volume written from the IOPS. And also Aurora, there are some cost optimization techniques and also particularly around how big create partitions. That's, I think, a lot of the techniques has already been widely adopted by the application team. But we do see some legacy SQL applications or the SQL data models not being partitioned properly because that has been developed more than 10 years time, and they definitely need to be reviewed and start to adopting more modern techniques. And also use your SQL costs, use your cost explorer wisely to understand what is the cost by using the tag and the usage type. For example, you need to understand what's the difference between the instance cost and the non-instance cost of your RDS environment. The instance cost just covers your compute and store, your compute and memory, and the non-instance is your IO cost. And there are a lot of tools we already mentioned. Use the AWS budget. The CloudWatch is very, very important to surface all the metrics of key performance indicators. And also the trusted advisor will give you some not very specific, but some general guidance around how to optimize, especially around the utilization or underutilized RDS instance, and also use the cache more to help you to get a smooth transition while you are reducing your instance type. So these are some very important techniques: cache, and proxy. So the last thing is what you can get extra cost optimization or savings from outside from the reserved instances, IOPS provisioning, is the modernization. As I just keep point out, so a lot of the cost benefit you get, especially from your data infrastructure, is through your continuously optimize your infrastructure, also your architecture. So, for example, I have a customer that experienced a series of architecture changes from multi-region to a multi-AZ environment, and then once they reduce the multi-region to the multi-AZ, they move the environment from the EC2-based database platform into the RDS, so which use more and more managed service to reduce the extra labor, the operational cost. Once they moved to the RDS, that's not the end of their journey. They upgraded the database version and they adopted Graviton continuously. They convert 90% of their RDS instances from Intel-based to Graviton-based to give them the extra 33% of the compute discount. So overall, within 4 months, they achieved the overall database cost reduction by 32% because they measure the cost to serve to their end users. They got that numbers very exciting, and they also passed 25% within these cost reduction, within these 32% of cost reduction to their end user billing. So the customer, their end users was become very, very happy, and also they achieved their annual goals for cost reduction and end user billing number. Now, this is, I think, a very compelling story to give everybody a understanding of your continuously modernization, your data infrastructure, your RDS, how you store your data, use your data is very important to get extra benefit from the modern cloud and native architecture. Right. So here we finished off all the RDS related, but your data infrastructure is not just limited to the RDS environment. It's just not just a database. You will have your data warehouse in the using the Azure Redshift or somewhere else. How do you optimize these? So particularly database, data warehouse, the ADW Enterprise Data Warehouse is a very compute intense instances because they do a lot of the column calculations, and also the query sometimes will be less because we do the compute quite a lot to create the data set that is ready to serve for your BI report. So what we can do is still the same, always use the next generation of node type. The i3 versus the traditional DS, the i3 got really, really good cost benefit, and also the free tier, try to leveraging that, and also considering the spectrum because the hot tier of Redshift storage is quite expensive. You do not hot tier store your data into the hot tier all the time because in the traditional data warehouse environment, pretty much your SAN is everything on the hot, but no cost to you. In the cloud environment, think about the tiering strategy of your data. And also considering using Athena when part, but the Athena can be used to limited the access of full scan of the RDS environment. And also the right sizing considerations, the node type, the instance, the reserve type is very important because Redshift currently is not eligible to savings plan. So finding the right node, the right instances, and reserve it for a long term is quite crucial for your data warehouse cost savings. So here is the sizing considerations, the quick factors of cost, the sizing and the performance indicators. So you can use that as a reference, and you can see if it's on demand, the cost difference is very, very, very high. And also use the pause and resume function, because if you are just using traditional BI reporting, you may not be the end user may not access that 24/7. So pause and resume your Redshift instances while off the peak time is another technique, because you can leveraging the on-demand billing features to reduce your cost significantly. You can maybe reduce this 30%, and the concurrency scaling to provisioning a very small, that needs a little bit of architecture techniques to make sure your front end, your data structure and also your front end visualization layer can coping with that concurrency scaling. And also use the Cost Explorer tools to understand and monitoring your AWS Redshift cost, especially the reservation rate. The reservation coverage rate is also very important. And also, I won't cover more of these slides. It's just tells you how to break down and deep dive and drill down your cost using the Cost Explorer. And also use the Redshift Advisor. That will give you the optimization point, actionable, for example, highlight or surface some idle clusters, and also give you some advices around when you should use the compress features on your Redshift instances. Cool. And also regularly go back and check your trusted advisor. That will give you a holistic report of what you need to do. So this is all about
before you jump into DynamoDB. Also Redshift Serverless is GA, I believe, and available in many regions. So there's also another one to look into if you have a bit of inconsistent workloads.
Cool. Yes. So thanks, Casey, for that add-on. And also, while you start to modernize your data infrastructure, you will start using more purposely built data stores to store your data into the right format and to the right services. So DynamoDB is a very, very commonly used data stores for non-SQL workloads. And because of the Dynamo is a serverless, so in the serverless environment, managing the capacity is the key. So use the reserved capacity for predictable workload. For example, you have a 40% of the static workload. You can measure that and reserve that capacity, and utilize the on-demand and auto-scaling feature of your DynamoDB that has been built really, really robust. So you don't need to run everything on demand. So this is the key point, because people not aware that DynamoDB can have the reserved capacity, not just EC2, not just RDS. DynamoDB is also a reservable service that you can leveraging. And also the capacity, the configurations, as well as, I'll keep emphasizing, design the data architecture, design your queries around how to use your DynamoDB wisely, because the capacity is directly associated with how much data, how much query you need, the DynamoDB need to serve. Plan your data, because I have seen many architectures, data engineers come to us to asking, how can I optimize my DynamoDB cost? Because I think DynamoDB is expensive. The answer is, that's not expensive. We can help you to optimize from the architecture perspective, and particularly from your application perspective, how you access your data, not using your old style SQL query data, SQL type of query mindset to query DynamoDB. There are a whole set of the different mindset we should use, instead of scanning the entire database, finding what you need from the keyword, using some other techniques, right, from the architecture level. And also use these tools, CloudWatch, to closely monitoring your capacity. That will give you an understanding of how much you improved and what is the current situation. And yes, Also, DynamoDB Cost Explorer give you a deep dive of different query types that being sent into the Dynamo. You can use the tag for different DynamoDB instances and the type groups. So once you reach that, and also there is another serverless topic. The more and more services will be introduced as a serverless, like Redshift, as a case you just mentioned. RDS has Aurora has a serverless offerings, and also Lambda has become a unneglectable part of your modern data infrastructure. You use more and more Lambda to processing and ship your data. How to handle the cost of your Lambda by processing large volume of data? That's another set of questions, right? There are some tools like Lambda power tuning tools that can help you to find out what's the balance point between the Lambda memory allocation and the processing time to get the best performance versus the cost ratios for your Lambda function. So more than happy to expand and continue talking about more on the serverless environment of your data infrastructure. That's all for today's session. And thanks for attending.
Yeah, thank you, Zen, for going through that and actually taking time of your day. It's can be quite a complex topic, especially because we didn't really go into the nitty gritty of the difference between NoSQL and SQL in terms of like what advantages and disadvantages they both have as well. But just I wanted to touch on something really quickly before we close out. And if you do have any questions, now is the time to ask if you are viewing this. I really when it comes to data, it's not just this infrastructure layer that Zen has actually gone into a lot of detail about. A lot of it also comes down to making sure you have those best practices when it comes to application development, making sure you have those code reviews in place. You are always looking at, are we getting the minimum amount of data we need from a database? Are we actually using the database appropriately? Because the amount of times I've seen a developer stick a query in a for loop kind of horrifies me, because now you've actually just made your access to your database, order in, which doesn't scale very well, surprisingly, and tends to lead to some really lovely database crashes. So do think about it like not only from the infrastructure level, but the application and the human aspect of it as well, and just put those guardrails around it. And you'll see that the integration test side of things really will help and bring that to light, because not only as part of the integration test should you say, does this work? There should also be something looking at the metrics of the underlying database, because when you run those tests, if the IO spikes to some crazy number or the CPU spikes and gets pinned at 100%, even though those tests might work, I would still consider that a failed integration test and shouldn't be pushed to production until I know why my UAT environment got pinned to 100% CPU for like 5 minutes. So thank you again, Zen. Thank you for everyone who watched throughout this. And as always, Mati wa, and enjoy your weekend. See ya.
Thanks.